Hi, I'm Rowan, the physicist, and this is Holt, the assistant physicist. Today we are going to be proving Newton's third law, which is for every force, there's an equal and opposite force reacting on it, okay? So let's look at the board. We have three scenarios here. I am represented in red and Holt is represented in black. I have a bigger mass than Holt. In the first scenario, I am running fast towards him and he is running slow towards me. In the second one, I am running slow towards him and he is running fast towards me. In the third scenario, we are running towards each other at the same speed, but our masses remain constant. I always have a bigger mass than Holt. So Holty, who's going to exert a bigger force onto each other? Me with a bigger mass running fast towards you, or you with a bit smaller mass running slow towards you?
You.
Good. Okay, I'm going to write that down. Who do you think is going to exert a bigger force in experiment 2? Me running slow towards you, or you running fast towards me?
Me.
Okay, write that down. For the last situation where I am running towards you with the same speed as you are running towards me, who will exert a larger force?
Same.
Okay, let's go over our hypotheses. So, when me with a bigger mass is going fast towards Holt with a slower mass, I will exert a bigger force. When I am running slow towards Holt and Holt is running fast, he will exert a bigger force. But when we are running the same speed towards each other, we will exert an equal force. Here's how we are going to test this hypothesis. We have springs here. Holt is going to have one spring, I will have another spring. The springs represent the force. So the amount the spring compresses, the amount of force there is. Okay, let's go. So we realized that if we just run into each other, it's going to be hard to make the springs align exactly. So for the first experiment, Holt is just going to stay still and I'm going to go quickly into his spring, like here. I'll go like this, and the books that I'm holding represent how I have more mass than he does because he's not holding anything. Okay, so hold your spring, please, Holty. So the camera can see, make it straight. Okay. So we're gonna look at the spring, see how they react. I'm gonna go quickly into Holt. 3, 2, 1. Good. Now for experiment 2. I'm gonna stay still and Holt is gonna go quickly into me. Go. Good. Now for experiment 3, we're gonna go quickly into each other. 3, 2, 1. Perfect. Now let's watch the videos in slow-mo and go to the board. Okay, so now we watched the slow motion videos and we're going to say what Holt is going to tell us what we saw. So, Holty, for the first scenario, what did the springs look like?
Same.
Good. I'm going to write that down. And for the second scenario, what were the springs like?
Same.
Good. What were the springs like?
Same.
Good. So let's review. When I, with the bigger mass, was going fast towards Holt with the slower mass, the forces were the same. When I was going slow and he was going fast, I still have the bigger mass, the forces were the same. And when we were both going towards each other at the same speed, even though we had different masses, the forces were the same. This proves Newton's third law. So Holty, we just proved Newton's third law, that forces that are exerted onto each other are equal and opposite. So when you are standing on the floor, the force that you are exerting on the floor is the exact same as what the floor is exerting on you. And when a mosquito collides with a truck on the highway, the forces they exert on each other is the exact same. Isn't that crazy?
That's not true.
What, then a mosquito and truck don't have the same forces applied onto each other?
Well, a truck is stronger than mosquitoes.
Yeah, you're right. A truck is stronger, but we just proved it. I have a bigger mass than you, and when I was running faster than you, or when I was moving my arm faster than you, I had a bigger force. We just proved it. It sounds really crazy, but it's true. So join us next time when Rowan, the physicist, and Holt, the assistant physicist, prove something else.